November 18th, 2025, 11:20 UTC. Across the world, the internet began to break. Not all of it, just the parts that mattered. Discord went silent. ChatGPT stopped responding. X froze mid-scroll. Shopify stores displayed error messages instead of checkout pages. And in offices from San Francisco to Singapore, the same phrase echoed, "Is it just us?" It wasn't. 20% of the internet, the websites, apps, and services that 2 billion people use every day had just stopped working. The culprit wasn't a cyber attack. It wasn't a natural disaster. It was Cloudflare, the company trusted to keep the internet running, crashing under the weight of its own configuration change. 17 days later, it happened again. At Cloudflare's operations center in Austin, Texas, the overnight engineering team was wrapping up a routine database maintenance task. They were adjusting permissions on a ClickHouse cluster, the kind of background work that happens thousands of times across tech companies every day. Nothing about the change seemed unusual. The permissions update was documented, reviewed, and approved. At 11:05 UTC, the change went live. What the team didn't know, what nobody could have predicted in that moment, was that their permissions change had altered a database query. The query now returned duplicate entries. Those duplicates fed into an automated system that generated a feature file for Cloudflare's bot management system. The file, normally around 20 kilobytes, suddenly doubled in size to 40 kilobytes. 40 kilobytes, smaller than a thumbnail image, barely enough data to notice. But this wasn't just any file. It was a configuration file that got pushed automatically to every server in Cloudflare's global network. 330 data centers, hundreds of thousands of machines, all of them within minutes received the oversized file, and then they started crashing. Sarah Martinez was in a Zoom meeting with her design team in Brooklyn when Canva stopped loading. "Give me a second," she told her colleagues, refreshing the page. The screen went white. Then came the error, 500 internal server error. She switched to Slack to message IT. Slack was down too. Across Manhattan, a trading floor at a major investment bank watched their dashboards freeze. In London, hospital staff found themselves locked out of patient management systems. In Tokyo, a gaming tournament ground to a halt when players couldn't connect to League of Legends servers. The pattern was always the same. Services weren't slow, they were simply gone. Replaced by cryptic error messages that meant nothing to most users, but everything to the engineers who understood what they signified. Cloudflare's proxy layer, the system that routes requests between users and websites, had stopped functioning. By 11:30 UTC, Downdetector was registering over 12,000 reports for X alone. The number would climb past 435,000 reports for Cloudflare itself within the hour. But even Downdetector struggled to stay online. It too relied on Cloudflare. The irony wasn't lost on anyone. At Cloudflare headquarters, the incident response team assembled within minutes. The monitoring systems were screaming. Every dashboard showed the same thing: catastrophic failure rates across their entire network. The team's first instinct was correct. They identified the oversized bot management file almost immediately. At 11:45 UTC, they pushed a rollback, reverting the database permissions change that had started the cascade. But nothing happened. The rollback removed the bad file from the generation pipeline, but it didn't fix the servers that had already crashed. Those machines were stuck in what engineers call a panic state, a kernel-level failure where the operating system can't recover on its own. Here's where the architectural decisions made years earlier came back to haunt them. Cloudflare had built its system for speed and efficiency. When the proxy software encountered the oversized file, it tried to load the entire thing into memory. The file exceeded the allocated buffer size. The software, written in Rust and designed to fail safely, did exactly what it was programmed to do. It panicked and crashed. The problem? There was no automatic recovery mechanism, no graceful degradation, no failover to a known good configuration. The system was designed to stop rather than risk running with corrupted data. A reasonable choice in most scenarios. Catastrophic in this one. Every affected server needed to be manually restarted. And with hundreds of thousands of machines spread across 330 data centers, manual meant slow. Recovery didn't happen in waves, it happened in stutters. Some regions came back online within an hour, others took 3. The company status page, when it could be accessed, showed a patchwork of green and red indicators that shifted minute by minute. Users refreshing websites saw a cruel lottery. Sometimes the page loaded, sometimes it didn't, depending on which data center happened to handle the request. For businesses, the damage was immediate and measurable. Shopify merchants watched Black Friday preparation traffic vanish. An e-commerce platform processing $10 million monthly burned through an estimated $500,000 per hour of downtime when accounting for abandoned carts and customer attrition. But the broader economic impact was harder to quantify. How do you measure lost productivity when ChatGPT, used by millions for writing, coding, and research, goes dark? How do you calculate the cost when X, a platform that drives real-time news and emergency communications, falls silent? Financial analysts attempted estimates: direct e-commerce losses, $180 to $360 million, total economic impact across all affected platforms, potentially exceeding $600 million for those few hours. Cloudflare's stock price told its own story, dropping 3.9% in pre-market trading and erasing $1.8 billion in market capitalization. By 17:06 UTC, nearly 6 hours after the first failures, Cloudflare declared full-service restoration, but restored didn't mean over. In the aftermath, Cloudflare's CEO, Matthew Prince, issued a public apology that acknowledged the severity. "We took down part of the internet," he wrote. "Our sincere apologies to customers and the internet at large." The engineering team published a detailed post-mortem. They outlined specific improvements: better validation of configuration files before distribution, the ability to quickly disable features globally if problems emerge, enhanced monitoring to catch size anomalies, and architectural changes to prevent one component failure from taking down the entire network. Industry analysts noted the transparency. After years of watching companies issue vague statements about technical difficulties, Cloudflare's willingness to publish technical details felt refreshing. But transparency alone doesn't rebuild trust. The real test would be whether those promised improvements could prevent another incident. The answer came 17 days later, 8:47 UTC, Thursday morning in Europe, afternoon in Asia, middle of the night on the US West Coast. Websites started throwing errors again. This time the outage was shorter, just 25 minutes, but in some ways it was worse. The November incident happened during off-peak hours for US businesses. This one hit during prime European business hours and peak traffic periods for Asian markets. Discord, LinkedIn, Zoom, PayPal, Uber Eats, all down simultaneously. And this time, everyone knew exactly what was happening. Social media exploded with a mix of disbelief and dark humor. Is Cloudflare down again? Wasn't a question, it was a statement. The cause was different, but the pattern was identical. Cloudflare's team was trying to patch a newly disclosed security vulnerability affecting React server components. They increased a buffer size in their web application firewall to protect customers, a reasonable security response. But they made the change using a global configuration system that pushed updates to all servers simultaneously, the same type of instant network-wide deployment that had caused November's cascade. And because the safeguards promised after November weren't fully implemented yet, the change triggered a parsing error in their FL1 proxy software. 25 minutes of global disruption, millions of users affected, and one damning realization: the fixes weren't in place yet. 2 outages, 17 days apart, completely different root causes, identical failure modes. This is what worried the analysts. If the December outage had been caused by the same issue as November, it would have been embarrassing but understandable: a fix that didn't fully work, a problem that persisted. But these were separate, unrelated failures: a database permissions change, a security patch deployment, 2 different systems, 2 different teams, 2 different decisions. What they shared was something deeper. Cloudflare's architecture prioritized speed and global reach over resilience and gradual rollout. Configuration changes propagated in seconds across the entire network. There were no stage deployments, no canary servers testing changes before they went global, no automatic rollbacks when metrics spiked. The system was optimized for the 99.99% of times when changes worked perfectly. It had no safety net for the 0.01% when they didn't. And at Cloudflare's scale, powering 20% of all websites, 0.01% meant billions of users. The financial losses were calculable. E-commerce platforms could count lost sales. Advertising-driven services could measure missed impressions. Stock prices provided a numerical reckoning of investor confidence. The surgeon who couldn't access patient records during a procedure, the student whose scholarship application deadline passed while university portals were down, the small business owner watching their store go dark during their busiest sales hour, unable to explain to customers why checkout wasn't working. These weren't just technical failures, they were moments when the invisible infrastructure of modern life became suddenly painfully visible. When people realized just how much of their daily existence depended on systems they didn't understand, couldn't control, and shouldn't have to think about, trust, once broken, doesn't recover on a timeline measured in hours or days. It erodes gradually and returns even more slowly. In the weeks following the December outage, enterprise customers began asking harder questions during renewal discussions, not just what happened, but what guarantees can you provide this won't happen again? The honest answer, the one that anyone who understands complex systems would give, is none. Modern internet infrastructure is too interconnected, too automated, too optimized for efficiency to guarantee perfect reliability. Every company makes trade-offs: speed versus safety, automation versus oversight. Cloudflare's architecture reflects choices made when the company was smaller, when rapid deployment was survival, when move fast was the mantra that built tech empires. The question industry experts debated wasn't whether Cloudflare would improve their systems. They would. They'd already started implementing the safeguards that should have been in place before December 5th. The real question was whether the fundamental architecture could be made resilient enough to prevent the next cascade, or whether the scale and complexity of modern internet infrastructure meant these failures were inevitable. Cloudflare's double outage didn't happen in isolation. 2025 had been a brutal year for internet infrastructure. AWS suffered a major outage in October. Microsoft Azure went down days later. Google Cloud experienced a 3-hour authentication failure in June. Each incident shared similar characteristics: routine changes cascading into catastrophic failures. Cisco ThousandEyes, which monitors internet reliability, logged 12 major outages in 2025, up from 10 in 2022 and 13 in 2023. The raw number of incidents remained relatively stable. What changed was their impact. As more businesses migrated to cloud infrastructure, as more services consolidated around a handful of major providers, each outage affected more users. The internet wasn't becoming less reliable, it was becoming more concentrated, and that concentration made every failure more devastating. Experts called it the too big to fail problem, migrating from banks to infrastructure. Cloudflare, AWS, Microsoft, Google, these weren't just companies, they were critical utilities. When they failed, the ripples touched billions. 2 months after the December outage, Cloudflare published updates on their remediation efforts. They'd implemented staged deployments for configuration changes. They'd created global kill switches for critical features. They'd enhanced monitoring to catch anomalies before they propagated network-wide. Some customers returned, others didn't. A new market emerged almost overnight: multi-CDN strategies, where businesses distributed traffic across multiple providers, accepting the complexity and cost to avoid single points of failure. Insurance companies began including cloud dependency risk assessments in policies. Job postings for resilience architects multiplied. An entire industry emerged around the premise that the infrastructure everyone depended on would inevitably fail, and the question was just how prepared you'd be when it did. The outages became case studies in engineering courses. They appeared in business school curricula about operational risk. They were referenced in congressional hearings about internet infrastructure regulation. But for the engineers who lived through those incidents, who spent hours manually restarting servers, who fielded angry calls from customers, who watched in real time as their systems failed globally, the lessons were more personal. They learned that perfect reliability is impossible, that every optimization creates new vulnerabilities, that systems designed for normal operations often fail catastrophically when something goes wrong, that transparency matters, but only if it leads to meaningful change. Most importantly, they learned that infrastructure is only invisible when it works. Today, Cloudflare systems are more resilient. The specific failures that caused November and December's outages have been addressed. The company continues to grow, adding customers, expanding services, processing more traffic, but the fundamental challenge remains unsolved. How do you build systems that must never fail when failure is inevitable? How do you serve billions of users across hundreds of data centers with the speed they demand and the reliability they deserve? How do you balance the need for rapid security updates against the risk of rapid failures? These aren't just Cloudflare's questions. They're the internet's questions. Every major infrastructure provider faces the same tensions. Every company that relies on them navigates the same trade-offs. The outages are over, the systems are restored, life returned to normal, which for most people means forgetting that any of this happened. But somewhere, right now, an engineer is deploying a configuration change. A database query is returning unexpected results. A feature file is growing slightly larger than anticipated. An automated system is propagating an update across a global network. On November 18th and December 5th, 2025, we learned what happens when most of the time isn't enough. When infrastructure fails not from malice or negligence, but from the inherent complexity of systems designed to do impossible things at impossible scales. We learned that the companies we trust to protect us from cyber threats can become the threat themselves, not through malicious intent, but through cascading failures that no single person could predict or prevent, because there will be a next time, different company, different cause, same fundamental fragility. The internet didn't break twice in 30 days because Cloudflare was careless or incompetent. It broke because we've built a technological civilization that assumes everything will work, that treats failure as an aberration rather than an inevitability, that optimizes for efficiency at the cost of resilience. November 18th and December 5th weren't isolated incidents. They were symptoms of a deeper problem, and that problem is still here.